In this recording, I will use question 4 from chapter 7 end of chapter questions to illustrate how to use Excel spreadsheet to solve a share price with a non-constant gross dividend valuation model. Cascade Mining Company expects its earnings and dividends to increase by 7% per year over the next 6 years, and then to remain relatively constant thereafter. From this sentence, we know that there are two dividend growth rates for Cascade Mining Company. The dividend first grows at 7% per year for the first 6 years. I write down this information as G1, 7% for the first 6 years. Starting from year 7, the dividend remains relatively constant. That is, the dividend does not grow over time. I write down this information as G2, 0%, year 7 thereafter. The firm currently, that is, as of year 0, pays dividend of $5 per share. I write down this information as D0, $5 per share. Determine the value of a share of Cascade stock to an investor with a 12% required rate of return. I write down this information as KE, 12%. Now, instead of drawing the cash flow timeline associated with this problem, I create the cash flow timeline using the Excel spreadsheet. I first write down time in cell A6 to indicate that the number shown below row 6 in column A represents the year. I begin by labeling the current year, year 0, in cell A7. Next, instead of typing down 1, 2, 3, 4, and so on, starting from cell A8, I use a formula to help me do the job, because the value of each cell is fixed at a 1-year increment from the previous cell. I therefore formulate the value in cell A8 as the value from the previous cell, that is, cell A7 plus 1. This formula applies to all the time periods, so I can simply copy down the formula to fill out the time periods. I can easily do so by dragging down my cursor. The first step of implementing the non-constant growth dividend valuation model is to calculate the dividend of each period during the non-constant growth period and the first dividend for the constant growth period. To write down these dividends in the spreadsheet, I first write down dividend in cell B6. to indicate that the number shown below row 6 in column B represents the dividend at the different corresponding time period. The value in cell B7 represents the dividend at the current period, year 0, that is, D0, given in cell B3. Therefore, we can get the value of cell B7 by creating a cell reference. To do so, I first type equal sign and then click on the reference cell B3 and then press enter. Now, the dividend at each period can be obtained by the formula the dividend at the previous period times 1 plus growth rate. The value in cell B8 represents the dividend at the end of year 1. To enter the formula into cell B8, I first type equal sign. Then the first term of the formula is the dividend at the previous period, which is D0, given in cell B7. So I click on B7. I then type multiplication symbol followed by the opening parenthesis and 1 plus the growth rate, which is given in cell B1. So I click on cell B1 and then I type the closing parenthesis. I have completed the formula in cell B8, so I click on enter. The formula created in cell B8 applies to all the other periods, so I can copy down the formula to complete the dividend information needed. Before doing so, I'm going to modify the formula in cell B8 a little bit by adding dollar sign in front of B and 1. I then press enter again to make sure I modify the formula successfully. By modifying the formula we just showed you, it guarantees that when we copy down the formula, the reference cell of the growth rate will not be changed. Now, I can drag down the cursor to cell B14 to copy down the dividend formula. We can see that I now have the dividend information up to the year 7, D7, which is the first dividend for the constant growth period. Now, I have to change the dividend formula in cell B14 a little bit because now the dividend growth rate is no longer 7% given by cell B1, but 0% by cell B2. So I have to change the reference cell to cell B2. And once I finished the revision. I have to press enter again to complete the revision of the formula. Once I finished the revision of the formula in cell B14, I now have the dividend information needed to implement the non-constant gross dividend valuation model. The second step is to step forward to the end of non-constant growth period and summarize all expected future dividends for the constant growth period into one equivalent value at the end of the non-constant growth period. In this example, we step forward to year 6 and summarize all the expected future dividends starting from year 7 into one equivalent value at the end of year 6. I have this value calculated in cell C13 by applying the formula of the constant gross dividend valuation model, which is the dividend next period divided by the investor's required rate of return minus the constant growth rate. I first type equal sign, then the dividend next period, which is D7 given in cell B14. So I click on cell B14 divided by the opening parentheses. Then the investor's required rate of return given in cell B4. So I click on cell B4 minus the constant growth rate given in cell B2. So I click on cell B2, followed by the closing parentheses. The formula is completed, so I press enter to build the formula in cell C13. The number shown in C13 is the equivalent value at the end of year 6, summarizing all the expected future dividends starting from year 7. The third step, that is, the last step, is to obtain the present value of all 6 expected uneven cash flows and the interest rate used to obtain the present value is the investor's required rate of return. I first generate the present value interest factor. I type present value interest factor in cell D6 to indicate that the number shown below row 6 in column D represents the present value interest factor corresponding to different time periods. The formula for the present value interest factor for each time period is 1 divided by 1 plus interest rate raised to the power of the corresponding time period. So, in cell D7, I type equal sign and then 1 divided by the opening parentheses, 1 plus the interest rate, which is the investor's required rate of return given in cell B4, So I click on B4 followed by the closing parenthesis, raising to the power of the corresponding time period, which is 0, given in cell A7. So I click on cell A7. I add $sign in front of B and 4. So when I copy down the formula, the reference cell for the interest rate will not be changed. The formula is entered completely, so I press enter. The formula in cell D7 applies to all other time periods, so I can copy down the formula to easily generate present value interest factor corresponding to different time periods. I complete this step by dragging down the cursor. I now type present value in cell E6 to indicate the number shown below row 6 in column E represents the present value. The value in cell E8 represents the present value of the dividend at the end of year 1. It is calculated by the formula the dividend at the end of year 1 D1 times the corresponding present value interest factor. I therefore create the formula by typing equal sign and then the dividend at the end of year 1 given in cell B8 by clicking on cell B8 times the corresponding present value interest factor given in cell D8 by clicking on cell D8. The formula is entered completely, so I press enter. The formula created in cell E8 applies to the calculation of the present value of dividend at the end of year 2, year 3, year 4, year 5, and year 6 respectively. So I drag down the cursor to complete the value. Now, at the end of year 6, the cash flow actually consists of the dividend at the end of year 6 and P6, which represents the equivalent value of all expected future dividends starting from year 7. So, the present value should be the present value of the dividend at the end of year 6 and P6. Consequently, I revise the formula in cell E13 by changing the first term of the formula to include P6. It is done by respecifying the first term of the formula by opening parentheses, then the dividend at the end of year 6 given in cell B13 by clicking on cell B13 plus P6 given in cell C13 by clicking on cell C13, followed by the closing parenthesis. The revision is completed, so I press enter. We can now obtain the share price by summing the present values of the dividend at the end of year 1, the dividend at the end of year 2, the dividend at the end of year 3, the dividend at the end of year 4, the dividend at the end of year 5, the dividend at the end of year 6, and P6. That is, to sum up, sale E8 to E13. I have this value calculated in cell E14 by using the sum function. I type equal sum and then selecting the corresponding range from cell E8 to cell E13 and press enter. The value shown in cell E14 is the share price. Actually, I can bypass the calculations of the present value interest factor and the present values by calling for net present value function to obtain the share price. It is shown in cell E15. I type equal net present value. The first input is the interest rate used to calculate the present value, which is the investor's required rate of return given in cell B4. So I click on cell B4. And then the 6 corresponding future values, which are the dividend at the end of year 1 given in cell B8. So I click on cell B8. The dividend at the end of year 2 given in cell D9. So I click on cell D9. The dividend at the end of year 3 given in cell B10. So I click on cell B10. The dividend at the end of year 4 given in cell B11. So I click on cell B11. The dividend at the end of year 5 given in cell B12, so I click on cell B12. And then the dividend at the end of year 6 given in cell B13, so I click on cell B13 plus P6 given in cell C13, so I click on C13. Then press enter. The value obtained is the share price, which is exactly the same as we just obtained in cell E14.